Hi everyone. Welcome to this talk about Hdinsight, Hadoop, and Hive. My name is Cindy Gross and I'm a PM on CAT. CAT is Microsoft's customer advisory team, and we work on projects that are new and challenging, things that are pushing boundaries. In particular, I am on the BI team and I work a lot with BI plus big data, so how they work together, how you might use Power Pivot or Power View, for example, when your data set is being processed through Mapreduce or when you're working at volumes that you hadn't expected to work with before. And you can reach me at SQL Cindy on Twitter. I have a blog on MSDN, or you can reach me at cindy.gross@microsoft.com. I do want to take a second here to thank PragmaticWorks for inviting me to do this talk, and also apologize to anyone who was on the call a few weeks ago and I had audio problems. So I do apologize for the delay in getting the recording out after that. So today we're going to talk about what big data is and isn't. We're going to talk a little bit about Hadoop overall and Hdinsight, which is Microsoft's distribution of Hadoop and how that fits into open source. And then we're going to dive into Hadoop into Hive, and why in particular that's a good way for SQL Server professionals to get into the world of big data and the world of Hadoop. We're going to talk a little bit about how you use Hive along with SQL Server analysis services and your existing BI front-end tools. And we're going to look in particular at the create object statements, some of the queries that you might do in Hive, how they look like T-SQL, where they're the same and where they're different. And we're going to talk a little bit about your storage options, which is defined when you do your create table, and say what your formats and your structure are going to be. So when we talk about big data, it's a little bit of a misleading term. It's not necessarily about size. It might be. It might be you're talking about terabytes or petabytes that you couldn't store in an existing system. It could be that it was just too complex or expensive to process however much data you have, whether it's gigabytes, terabytes, or petabytes. Really, big data is about new technologies, new ways of looking at data, allowing you to process data that maybe you threw away or you couldn't use all of before. Maybe you've been storing it, but you haven't been able to process it, or maybe you can only keep a couple of years worth of data easily accessible. So now we're going to be able to use scale out technologies in order to allow you to process that data that was just going to waste before. Quite often big data is associated with schema on read instead of write. So what this means is that you load your data, and at this point, it's considered unstructured. It has no structure associated with it. Now, in reality, almost all data has some sort of structure. So you might hear the term unstructured, multi-structured, many-valued, all sorts of different terms like that. But what you do is at the time that you go to read the data, that's when you define the schema. You don't necessarily define it ahead of time. Now, when we use Hive in particular, we're putting some metadata out there that's going to persist. But if you're doing pure Mapreduce, which is one of the core components of Hadoop, which is one of the most common forms of big data, Mapreduce defines the schema every time you run a job, unless you are referring to Hive queries, in which case, again, you refer to the metadata that you create. But it is very easy to change and modify that structure in Hive. Also, big data quite often is talking about base instead of ACID. When you have ACID properties, you're keeping transactional consistency. You remove money from a checking account and you add it to a savings account all at once. One cannot happen without the other. That has a performance penalty and some amount of overhead. So when we have base, or basically available soft state eventually consistent, those pieces of the transaction might come into the system at different times. They're not necessarily guaranteed to come in together, but eventually they should be consistent. And this allows the system to avoid locking and some of the other things that can slow down performance. Big data also generally is about batch processing. It is not about the types of things where you're moving data around dynamically. It's about analyzing that data afterwards. So in the example of the moving data between checking and savings, how often do people do that? Do they tend to move large amounts of money? Do they move it back and forth? After they get their next paycheck, do they move money back into savings that they had originally moved into checking? It's for doing those sorts of analysis in batch later on after you've loaded the data or after the transactions are kind of quiesced. In big data in particular, it might refer to Mapreduce, which is associated with Hadoop. It might refer to streaming or event processing of some sort. It could be machine learning. It can be massively parallel processing. So it's not just Hadoop. Now, today we're mostly going to focus on Hadoop and in particular Hive, but big data is much bigger than that. And again, it's not necessarily about size. It might be gigabytes, it might be terabytes, it might be petabytes or exabytes. But it's about data that is bigger, more complex, or more expensive than what you could process in a traditional system. And it may be of a really large size, but it's about not having to throw away data that you were throwing away before. Now that you have all this new data or new ways to access data, you can ask new questions. You can bring in external data much more easily. You can bring in huge volumes of Twitter data or Facebook data, whatever social media you deem relevant to your business, and you're able to analyze that in combination and quickly do a mini what if types of scenarios. You don't have to predefine indexes or predefine queries. Now, there is a performance penalty for that. If you don't have indexes, it is going to be slower. You fix that with the scale out terminology or technology that we talked about before. So as you add more machines, you reduce the performance penalty of not having indexes. You can also ask questions such as, how do I optimize something? How do I change the order or the direction that I send my fleet of trucks out in? How do I change the shipping schedule for my factories or my retail stores? And in the end, you're trying to gain insights. You're trying to figure out, if I asked all of these questions, now instead of being limited to a set of predefined queries that match my aggregations or my indexes, now I can ask all sorts of questions and try to predict outcome. I may find that there's a correlation between things I never thought were related before. And again, this is impacted by being able to bring in external data sets. Does a CDC report or a disease outbreak affect sales in a retail store? Does the price of gas affect the way that my customers buy things? Does it change whether they buy things online or on premise in an actual brick and mortar store? So you can ask those questions that maybe were just too expensive to ask before. And again, this opens up new opportunities. So some really good examples of how people are using big data are listed here. We've got Yahoo, and they're able to process just tons of clickstream data and increase their ad revenue in ways that maybe they couldn't do before. So they're looking for new patterns and new correlations, and they're doing that by using Hadoop and analysis services. Cloud is similar. They're also using Hadoop and analysis services, and they're able to take lots of social media data, that includes Twitter and Facebook and many other feeds, and they're able to rank people by their influence on various keywords. And then from that, they're able to offer perks to these people that are considered influential in a certain area, and those perks allow them to allow these companies to increase their reach and increase their marketing through these influencers in the community. And again, that's all done on Hadoop and analysis services, and GE offers similar insights. So when we talk about big data, we can mean many different things. We can mean relational and highly structured databases such as SQL Server and PDW, or Parallel Data Warehouse, which is an addition of SQL Server. And PDW is a scale-out technology, which if you understand the control nodes and things like that, that makes it really easy to understand the Mapreduce terminology and technology within Hadoop, because they operate in very similar ways. It can be enterprise BI and analytics tool, all the way from Office up to analysis services. So the client side, such as Power Pivot, tabular model, which is a version of analysis services, up to analysis services, tabular, and UDM on the server side. You can also have Hadoop, Mapreduce. Within that, you have distributed storage. And Microsoft, again, offers Hdinsight as our distribution of Hadoop. And big data quite often involves multiple data sources, maybe including data sources that you couldn't bring in before, external data, multiple internal data sources, all sorts of mashing up of data in new and interesting ways. Event-driven processing, sometimes called streaming, where you're able to respond to data that is flowing through a query or flowing through a system. And then also we have lots of self-service BI tools as well. And all of this is offered both in the cloud for flexibility and on premises. And there are different variations of exactly what version of each of these technologies is in the cloud and what's on premises. And that's changing all the time. So just check with your team on whether what you have on any given point in time is going to fit better in the cloud or on premises. Hadoop is a natural fit for the cloud because it is about flexibility and it is about scale out, and that is very easy to do in the cloud. Also, because Hadoop is fairly new, a lot of people don't know how to use it, how to install it, how to run it, how to configure it. And if you go up to the cloud, to our Hdinsight offering, we can hide a lot of that complexity from you and let you concentrate on writing the code that is actually giving you the business insights. You can write your reports, you can write your analysis, you can do your machine learning, and you don't have to worry about somebody in your organization having to ramp up on the internals of Hadoop as well. So there's all sorts of different options for all of these tools. So I do want to take a step back. I get lots of questions on how is Microsoft integrating in with this open source technology. So you have an open source community where everything is free. People from the community write the code, they modify the code, they vote on whether changes to the code will be allowed in. And right now, Hadoop is managed as an open source technology by Apache. And what happens there is the core code for Hadoop is the same no matter who distributes it, whether it's Microsoft, whether it's Cloudera, whether it's someone else, everybody's using the same core code. In particular, we partner with Hortonworks. Hortonworks is a Microsoft partner. They are the founders of Hadoop. Many of the employees of Hortonworks, many of them are the ones that wrote Hadoop and wrote Hive in the first place. So they're a very good partner out there, and they're very heavy contributors to the open source code. And we partner with Hortonworks to do our check-ins back to Apache and to consume our code from Apache. So what we do is we take that core code, and Hortonworks helps us bundle that up and make sure that it runs really well on Windows. So we've had hundreds of check-ins back to the core code to make sure that it runs really, really well on Windows. And then we take that and we bundle it up as Hdinsight, which is now downloadable. And what we do is we have some things that we've added in. We've got JavaScript, we've got dashboards. If you go up to our Hdinsight service offering on the cloud, we've got new storage options that I'm going to talk about. We've added in monitoring, deployment, many things that aren't there in the core Hadoop product that is out in Apache. In particular, Hadoop is notoriously difficult to install, but in Hdinsight service, you simply go up, hit the deployment button from the Azure portal, and 10 to 15 minutes later, you have the cluster deployed and ready. And now you just go out and you can use PowerShell or whatever you want to automate the creation of your normal Hive tables or whatever it is that you need to push out into the system, and then you start running your queries. Once you're done with that set of questions, you can spin your cluster down and stop paying for it until you need it again. You can go out there and keep your data in an Azure blob store long term so that it persists across multiple Hdinsight clusters. So just to talk a little bit about what Hadoop is. So there's many, many different pieces of Hadoop, and it's really hard to get a complete picture of what it is. This is not necessarily everything that's out there in the Hadoop ecosystem, how that's defined, what parts are purely open source, what parts are add-ons that aren't part of Apache. That's changing very rapidly. But I've put the most important pieces or the most commonly talked about pieces on here. So in the red section here, we have distributed storage, or HDFS, Hadoop Distributed File System. And that has to do with the way that when data is brought into the system, it is scaled out across multiple data nodes. And this allows all of these different nodes in your Hadoop cluster to do processing. And they do that through distributed processing, or Mapreduce, which is the other red tile on this picture. And that allows you to have your data and your processing co-located, and it allows you to do scale out very impressively. And for certain types of operations, you can get linear scale. Going from 10 nodes to 20 nodes for some operations will double your performance or cut your execution time in half. That, of course, is not true across the board for every type of query, but there are cases where that can happen. And those are really the very most core components, your storage and your Mapreduce. Now for storage, one of Microsoft's improvements is down there below it in the purple, the Azure Storage Vault, or ASV. So we've taken the API that's available with HDFS and we've written some ASV code that allows you to access your data sitting up on an Azure Blob Store and reuse that data across multiple clusters or for other systems. So you could have data that is being processed by an existing program sitting in the cloud, and that same data is also available to Hdinsight. So moving beyond that, let's look at the items that are in blue. So Hive, we're going to spend a lot of time talking about, and that is a querying type of language. So if you want to take your knowledge of SQL Server and your knowledge of T-SQL and apply it to the Hadoop world, or if you want to use any of the BI tools that are out there, you're going to be using Hive, because that is the easiest way to get into the world of Hadoop if you're already familiar with SQL Server. It's also a very powerful language that's very familiar to many BI end users, because they're used to, if not necessarily directly writing SQL, using tools such as Excel, Power Pivot, Power View, Data Explorer that generate Hive queries in the background. Now, by default, Hive is going to generate Mapreduce code. So you don't have to write the Mapreduce code. You're hiding that complexity. Mapreduce programmers are few and far between, and they're very highly paid. So you want to try to abstract everything up as many layers as you can and avoid having to write that code on your own. Another way you can do that is scripting, and Pig is a very common language for doing that, and they'll carry the analogy very far. So you have Pig and you have Grunt, and within Grunt you have pigs who will eat anything. You know, there's all sorts of different rules and all sorts of fun analogies there. There's also hCatalog, which is metadata that is available across different systems. So when you create a Hive table, you're creating metadata. You can also create metadata in hCatalog, which is usable by Hive and Pig and other systems as well. One of the other blue items here is Hbase, and we don't currently have that pulled into our distribution. It's one of the core components, but it's not currently in ours. And we do plan to have it there. You know, it's just making sure that it runs well on Windows and that it does everything we need it to do, and it'll get there. Hbase is one of the few real-time components of the Hadoop ecosystem, and it's actually not used all that often for a lot of the new use cases that we have coming in. It's not necessarily the way you want to do batch processing or a lot of the introductory use cases for Hadoop anyway. So really, you're probably going to be spending most of your time with Hive and Pig. Now, one of the other items here is Oozie, which is a pipeline and workflow technology. We have Flume, which is an event pipeline. Like I said, we've added in several things. So we've added JavaScript. You can now write C#, F#, and .NET code. And then we also support access from Pegasus, R Hadoop, or R, and Mahout, which are different ways of doing very detailed analysis, machine learning, and different sorts of testing technologies. The things here in purple are things that are Microsoft specific. So you've got System Center up in Azure for monitoring. You've got all sorts of data that can be brought in externally. So we have the Azure Data Marketplace. You can certainly bring in data from other external sources as well. Azure Storage Vault, I already talked about, and Active Directory for security. PDW, in particular, the Parallel Data Warehouse edition of SQL Server, the most recent release, V2 of PDW, has what's called Polybase. So you can go into PDW, do a create table statement, and say that your source is Hadoop data. So you can point it out to Hadoop, and now you can query that data from within PDW. So you're able to say, join a SQL table and join a Hadoop table into a single statement and write that as your normal T-SQL query. So that's a very powerful feature in PDW, and it is called, right now, the code name is Polybase. Of course, SQL Server, Stream Insight, or RX are the event-driven processing technologies we currently offer, and then business intelligence via Excel, Power View, Power Pivot, analysis services. I do want to say that the Hive Odbc driver is what enables many of these things over on the far right to work. So we have a Hive Odbc driver, and it is, again, pulled from the open source code. Now, the way the open source code works is everything goes through an incubation period, and then it gets promoted. And once it's promoted is when most companies start pulling in that code. There is a Hive Server 2 that has been promoted, and we are working on pulling that into our code. It will greatly improve Odbc's performance and functionality. But for now, we're with the version that most people have, or in some cases, we're ahead of what a lot of other distributions have. But the next version of Odbc, once we have Hive Server 2 in, should be even more powerful. But it is what enables all of these BI tools or SQL Server to look at this data that is out in Hadoop and is, just scattered across many, many data nodes, and take that data and make it accessible as if it's just any other table that has rows and columns. And that's what it looks like once you impose a Hive metadata structure on it. And the Odbc layer then translates that up, and you can use a tool that can use Odbc, and now you can access all of this Hive or Hadoop data from Excel. Oh, and I do want to highlight here the sections in white are things we're working on. As I said, Hbase, we're working on getting that into our system. System Center is in the Azure version, but it's not yet fully complete. We have Flume and some of the security pieces that are currently being worked on, and look for those in the near future. So now I want to talk about the Hive architecture. So you've got Hadoop sitting out there hosting your data, running its Mapreduce code, and we hide that complexity from you with Hive. And HiveQL is the language that you use, HQL or HiveQL, and it is a structured query language. Like any of the SQL languages, it is not fully compliant with the standards. It looks very much like the MySQL version of the SQL language, and it has many of the BI functions and functionality that you would expect, but it doesn't have everything that most of the common SQL languages have. It certainly doesn't have a lot of add-ons yet, but it is rapidly evolving. It's also got many initiatives out there. For example, the Stinger initiative is part of the Apache open source that is expected to have huge improvements in the Hive response time. Right now, Hive is going out and generating Mapreduce in order to answer its queries. And Mapreduce is basically doing, for those of you in the SQL world, the equivalent of a table scan every time. There's no way to really eliminate data unless you pre-structure the data with partitions, and even then there's overhead, there are limitations, there are things that come into play there that really mean that you're doing the equivalent of a table scan every time. And some of the things they're doing with Stinger are going to improve that. Now, when that's going to become available at the open source level and when that's going to be able to be pulled into various distributions, I don't know. But it is something that's out there, and you need to think about that this is a very rapidly evolving technology, and things you learn today might not apply in 6 months or a year. The thing is, you use big data, and you use Hadoop and Hive in particular for what makes sense for when you want to do batch processing, for when you want to change iteration or quickly iterate through different schemas or different structures, when you want to ask questions you couldn't ask before, when you don't want to spend a lot of time up front pre-defining and pre-aggregating or pre-indexing the data, but you just want to go out and start asking questions, and you want to figure out what questions you want to ask. And then once you've got that well defined, you might pull it into a system that's faster or that's more real-time. You might pull it into SQL Server. You might pull it into analysis services. But back to the Hive architecture, you write HiveQL, which uses the metastore, and that goes down through either an Odbc or a JDBC layer. It might go through the command line interface or a web interface, but somehow or another it's translated down to a compiler and an optimizer, and it doesn't have much of an optimizer, I will say. It's very dependent on, say, the order that you put the tables in the from clause, for example, not something we're used to in the SQL world, but it does have that to some level, and you can modify it. Everything in Hadoop is highly customizable. It's written for a programmer. It's a programmer's tool by and for programmers. So everything is customizable. And that does include the optimization. So you can write your own custom SERDES, which we'll talk about in a little bit, and you write your own optimization for it. But the point here is that you write the HiveQL, and all these other layers are fairly transparent to you. It is mashed up down to the point where it goes out and queries the data and sends it back to the tool that you originally queried from, and you don't have to worry about all the complexity that's underneath, and that's one of the beauties of Hive. So why would we use Hive for Hadoop? I've already talked a little bit about this. It does enable the BI tools via Odbc, and it allows you to put structure on the data. It allows you to put it in a human consumable format. Humans are used to thinking in terms of rows and columns, and it's very easy to consume the data that way, especially for your people that are doing business analysis. It allows you to have structure without full relational modeling ahead of time. It allows you to go out and try a bunch of different things and iterate through it. If you make a mistake in how you think you might define the data, or if you don't yet know which questions you're going to ask, Hive's a great way to give it a try. Let's just throw something out there and see how it works. And you don't have a 6-month project to get the data loaded into a particular schema and then spend months fixing it if it wasn't quite right. You throw the data out there and you try a bunch of different structures, you try a bunch of different queries. It allows that rapid iteration. And one of the reasons that Hive is so powerful for people in the SQL world is that it's very familiar. HiveQL looks very much like T-SQL and lets you reuse the skills you already have. And it does just make it really, really easy to get into Hadoop. So what do we know about Hive? It's batch oriented. Again, it's kind of like doing a table scan. If you do a table scan in SQL Server on your one big machine, that's how long it's going to take. However long it takes to do the table scan is how long it takes. In the Hive world, if it's too slow to do your equivalent of your table scan, well, all right, let's add 5 more nodes. Let's add 500 more nodes. It's going to get faster. Now, how much faster, it may or may not be linear depending on the type of query that you're running and how you have your system set up, but there's a chance it's linear. So it is batch oriented, it's data warehouse focused, and you are doing table scan type of activity, but you're able to improve your table scan type of activity performance by doing the scale out and by adding nodes. Now, one thing is it does generate Mapreduce. So some people come and say, hey, is it faster than Mapreduce? Only for the most simple of queries. If you do a select star from, and that's all you have, you don't have a where clause, you don't have a join, you don't have anything else, it does not actually generate Mapreduce, it just streams the data. Other than that, for the most part, it is generating Mapreduce. And Mapreduce is still code that's written in Java. It has to be compiled. It has to be spun up on the system. It goes out and does all the Mapreduce stuff that I haven't spent any time on because there's hundreds of talks on that. But basically, Mapreduce is spinning up jobs. The jobs are being split into tasks. The tasks are being assigned to each compute node. Each compute node is finding where the data is. All of that setup time is negligible in terms of an overall table scan or batch oriented type activity. But if you expect to go and return 5 or 10 rows, your query is going to be faster in SQL Server than it would be in Hive because Hive is not written to do that level of activity. Has very limited indexing. In reality, in the current version of Hive, indexes are so limited, you're probably never going to create one. And again, that's rapidly evolving, but right now indexes don't do a whole lot. We'll talk a little bit about them later. There's basically no statistics and basically no caching. There are, again, limited exceptions to that, but when you're doing your planning, think of it as every time I run the query, if it took an hour last time, it's going to take an hour next time, unless I've added more nodes or reduced other load on the system. But assuming that everything else stays the same, it's not going to cache that data. The tasks might be assigned out to totally different nodes on the next time, so caching would be pointless. And really the programmer or whoever's writing the Mapreduce code, and in some cases the Hive code, is the one that's doing the optimization. The system is not doing any sort of cost-based optimization. Also, you need to think of Hive as something you're appending to. You're adding entire files, and you're adding huge files. You're adding all of the transactions from your online system from an entire day in a single file or a directory of files, for example. You are not going out and inserting or updating or deleting an individual row. And for the most part, most people want to never delete anything in Hive or in Hadoop in general. So for the most part, think of it as you're only adding data to the system. You're not updating, inserting, or deleting. So again, why do you as SQL Server people care about Hive? Everybody, every organization out there is getting pressure to do big data. It is the buzzword. It is the hype. It is the wave of the future. Now, is it going to be the one and only thing that's out there? Is it going to save us all? Is it going to, revolutionize the world? Well, no, but it is something that is new. Nobody really knows it at most companies. Now is your chance. Now is when you need to get in there and learn it and become the expert on it, because nobody out right now really knows a whole lot about it. It doesn't take much to be the expert on the system. So it's a great opportunity. It's great for your career. It's a way to get in there and make sure that you understand how it works enough that when a project comes along and somebody says, hey, this project's a good fit for big data, you can say yes or no. And you can also say, well, within the big data world, maybe this is a PDW fit. Maybe this is a Hadoop fit. Maybe it's a SQL Server fit. There's all sorts of different ways to approach things within big data. And even within Hadoop, Do I use Hive? Do I use Pig? Now's the time to get in and learn enough about it that you get to make those decisions and other people aren't making those decisions for you, because it is very easy to just throw every new project into that hype and the buzzword. But it really is about opening up possibilities and adding tools to your tool set. It's not about replacing things. And what you're going to find in most cases is if a project was really working well in SQL Server, it's probably not something that's going to get moved into the Hadoop world. They have very different characteristics of how they work. You know, the whole idea of transactional consistency, for example, many systems could never be moved into a Hadoop world because there is no transactional consistency. So don't think of it as something that is attacking your job or taking away from your job. It's opening up possibilities and adding new things, and it can become a new data feed, a new data source for SQL Server or analysis services. It can become a new way of expanding how you use your data and letting you expand your horizons. Don't think of it as limiting you. And it does let you explore. There's all sorts of opportunities out there for exploring. You might be archiving, you might rapidly iterate through different things. You can aggregate your data in Hadoop and then load it into analysis services after, for example. You can go out and take algorithms or questions that you're not quite sure what exactly you wanted to ask, but before, once you defined it, you were kind of stuck with it. Well, now you can rapidly iterate through it and try out different algorithms, different ways of looking at the world or looking at the data. And also, in reality, it opens up a lot of self-service, and in some ways that seems contrary, but you've got all these new ways of looking at data again. And you've got these business analysts who couldn't get their projects through, who couldn't get somebody to dedicate the time to spend a 6-month project to get their data out there. Now they can say, it's up on Hadoop. Just go get the data, dump it out there, throw a Hive table on top of it. Let me explore. I'll tell you if the data is valuable or not. And if that self-service BI analyst decide, yes, that data is valuable, now you have some way to really tell, should I prioritize this? I've got some actual data. They've created their Power Pivot model out there, and that's kind of their requirement stock. Now you know what they need and how they use it and how they're combining and aggregating the data. And that will help you decide, is it worth taking this data and moving it into an existing system? Lots of other examples along those lines, but the world is changing, and it's either going to move on with you or without you. So we still need SQL Server and analysis services if you need to do updates, if you need ACID properties, if you're doing any sort of really querying individual rows or small subsets of the data. Once you have queries that are very well known and predefined, you probably need it in a relational type of system or a multidimensional system. That's not really what Hadoop is optimized for, at least not right now. And again, the whole world of big data is changing very rapidly, but you do really need SQL and analysis services, and quite often they work very well next to and alongside Hadoop. They're not necessarily competing, they are interacting with each other. And you can think in many ways of Hadoop as another data store that's out there and can feed your existing BI systems, your OLTP systems, whatever it may be. So what is going on behind the scenes? So when we get into Hive, we see many different things that are going on. And let's start with kind of how you impose your schema, how you create your metadata. And there's two basic ways to create a table, partitioned and non-partitioned. We'll also talk about internal and external tables. But for now, if you're going to create a table that is not partitioned, then you just say create table, you give it some data types, and then you go in and you say, here's what my format is. And for certain types of formats, you're going to give it field terminators, and you say what kind of format it's in, and you say where it's at. And there are all sorts of ways you can customize all of this, but this is a basic statement here. So this is a create table. I could have dozens or hundreds of columns out there, and we'll talk about the data types that are available later. They're fairly limited for very good reason. In this case, we've done row format delimited because we said the row format is delimited. We have to say what it's delimited by, and we're saying that it's delimited by a tab and that it is a text file. And in this case, I'm saying the location is in my default location, and then I've given it a string, which is a set of directories, and everything in that table will be in files underneath that directory. I'm not specifying one file. Other than demos, you should not have a single file that Hive is processing. You should be processing very large files, and there may end up being very many of them, but you want the files to be as large as possible, and you want to have many, many files. The other way to do it is to create a partition table. So the main difference between the non-partition table and the partition table is that you do not define your location in your partition table. You do that later with partition statements. So each partition that you add, you give it a different location. This lets you essentially do table scans that are partitioned. So you can scan just an individual partition, for example. Now there's more to it than that, but as it relates to SQL, I think that's a fairly good analogy. And again, this is going to vary depending on whether it's an internal or an external table, and there are different ways to do it. But this is a nice, concise way of looking at it. When you partition the table, you're still defining your columns, you're still defining what the delimiters or what the format of the file is, but you're separately saying, I want to have these partitions, and each partition exists in a location. And that lets you do things in parallel. It lets you do all sorts of different things with the partition. One thing to keep in mind, though, is that if you have defined partitions, you've now imposed some sort of structure on your data. It is a little bit harder to change the structure. So if you partition originally by year, and next time you want to partition by month, now you have to move your data to partition by month instead of year. Now, maybe fairly minor, and hopefully you're not changing your partition key very often, but it is one thing to keep in mind. It does make it a little less flexible in the system, but quite often the performance improvement is more than worth that. And once you download the slides, you'll see some examples in the notes of how you actually go out and download this. I also have a lot of the information on my blog, so there's examples in the notes on this for how you would upload the data, how you would put the data into Hadoop, and it is only one of many, many different ways to load the data, but I'm using the put command in the example, and then how you would create a sample Hive table and query it. So that is in the notes to the slide. So we're also going to look at some different things that I alluded to in the previous slide. So data types, again, the difference between internal and external is very small in the create statement, but can have huge, huge implications. And then we're going to talk about some of the different format and storage type of options that you have. Let's start by saying that the metadata is stored in a database of your choice. By default, it's Derby, and that is something that is defined at the Apache open source layer. You could also choose SQL Azure or SQL Server, and we're not really going to talk about how to do that right now, but it is something that you can do if you want to. And for the most part, again, you're not going to be going out to that underlying database and accessing the metadata directly. You're going to be doing it through statements such as the ones below. You'll be in Hive and you'll say show tables or describe and give a particular table name. And we'll talk a little bit more about these later on. Now, the data types are very limited. We have a small number of primitive data types. You have a variation in the number or numeric types. You only have one character data type, which is a string. And really, when you think about it, that is a great advantage because you're not able to control the data. You're not in control of what the data's format is. You could have a file added later that has, longer than the string you expected for a given column, or, things don't quite line up the way you originally thought. So you want these data types to be as flexible as possible. And we also have binary, and new in one of the later versions of Hive, which we do have, is pulled into our distribution, and not everybody has pulled it in, are timestamps, which are similar to date time. We also have collection type of data types, struct, array, map, and union type. I'm not going to spend a lot of time on those. The different ways you would define it are outlined here in the slide. Most of the time for your first initial foray into Hive, you'll probably be using the primitive data types. And if you need to use one of the others, Programming Hive is a great book, and it describes the more complex data types in enough detail that you could learn it. And also on the Apache site, there's some information on it. One thing to note is there are no fixed string lengths. Like I said, there's just string. That's all you say. And we're going to talk about SERDES, or serialization, deserialization, in a little bit, but the null handling depends on how the SERDE is written. So all of the examples I'm using are using a default SERDE, which is the text file. And if you want handling of anything to be different, you just write your own SERDE. So storage. When I create an external table, I'm specifying the location. So I can say, use my default file system And then here's a set of directories. And directory is kind of a funny term. They're not exactly directories. And I can say I want it to be an HDFS or I want it to be an Azure Storage Vault in particular. So you could have a mix. You can have a system that has data both in HDFS and in Azure Storage Vault. And you can do that either on-premise or in the cloud. Now, performance-wise, you're probably going to want to have your Hdinsight service cluster in the cloud and your storage in the cloud as well. Having it stored in HDFS within each data node, there may be cases where that's more performant, but in what we've found in our testing so far is that you're probably going to want it in the Azure Storage Vault. So when you have your data out in ASV, it is in a storage accounts store, and that's just something you define when you go out and you use your Azure subscription to create storage accounts, and those storage accounts have the data available within the data center. Your Hadoop cluster will be in the same data center as your data store, and the way that the system works, it's a very fast data access between all the machines in the data center. So it should be fine to use the ASV. If you have a need to have some sort of temporary data, whether it's intermediate storage or something like that, and you have your cluster in the cloud, you might choose an HDFS storage location where the storage is on an individual data node or all of the data nodes in the cluster. Exactly what those use cases are, we're still working out as we do testing and start rolling out new systems. But in general, you're probably, if you're using an on-premises version, you're probably going to use HDFS as your default location. And if you're using a service version or an Azure version, you're probably going to be using ASV as your default. And by default, that is the way it works out. If you install our one-box install, the on-premises preview version, HDFS is your default file system. If you install service, then or create a Hdinsight cluster in the cloud, ASV is your default file system by default. And whatever your default file system is, you don't have to specify it in your command when you create a table, when you load data, whatever it is you may do. An external table is probably what most of us are going to use most of the time. And you do have to use that keyword external, create external table. So if you want data that is used outside of Hive to be available, even after you've dropped a table, or to be used by something that needs to know the exact location ahead of time, you want to use an external table. If you want to use a custom storage location, you probably want to use an external table. And anytime that you want to be in control of the data, the control settings, the directories, you want to use an external table. If you want to use an internal table, you say create table. Internal is sometimes called managed, and actually if you look at a show table statement, or a describe statement actually for the table, you'll see it called either external or managed. So if it's a managed or an internal table, Hive is the one managing the location. It's managing when the data is when it's removed, which would be when you drop the table. So an internal table might be something you use when you don't want to mess with it. You don't want those details to be under your control. Maybe if you have some short-term usage, or if you're doing a select from another table, for example, create this new table based on some other table, which is only available for internal tables right now. And again, that may change in the future, but that's the current implementation. So I would say that most of the time you're probably going to be using external tables. And let's look at partitioning. I talked a little bit about this before. So it does, again, look different for an internal and an external table, but I'm going to stick with examples for external tables. And you can partition by a particular column, and then that column hopefully is not also in your data. If it is, you have to give that data in the table a different column name. You cannot call, in this example, both of them year. The assumption is the data does not actually exist. So maybe the file name or something else is going to tell you the year of the data. And you say everything from the year 2013 goes into some given directory. Everything from another year goes in a different directory. Therefore, you don't need that data stored in the actual files, and this can save you a lot of space. And again, we're quite often talking about terabytes or petabytes of data, so having just this metadata thing that gives the partition key value instead of having to store that value in every file is can be a big cost savings. Now, if you partition, you can choose to cluster by some other column into individual buckets. And again, this may be of limited functionality, but it is something that can be useful in some cases, such if you're going to do sampling or if you have certain types of aggregates or joins that you know you're going to do. So buckets may not be something you do in your first couple of projects, but it is something to be aware of, that you can cluster by buckets and split your data up in ways that spread the data out in known patterns. So something you're more commonly going to have to care about are the file formats. So basically you're going to say my file is a certain structure. I've gone out and I've looked at my set of files, and all of the files accessed by a given table are going to have the same format. Now you could probably write some very complex custom SERDI that would handle multiple formats, but in general the assumption would be you're going to have a certain format. You can hope that you're able to use the default, or that you're able to find a SERDI that exists out there, such as the ones for JSON or comma separated values. And you can refer to those, or you can write your own in Java. And if you do write your own SERDI or your serialization, deserialization format, you also have to include any optimizations. And again, that's one of the reasons why optimization is so limited, and how you write your Hive query is very important, such as the order of the tables in the from clause. But you can say it is stored as a certain type of file, such as a text file or a sequence file. One thing that is not necessarily intuitive is that generally you want to remove headers. None of the default SERDIs, at least not the commonly used one, and certainly not the default if you don't specify a SERDI, none of those account for a header. So if you have a header, and especially if you have a header and another line in between, you would have to manually remove those from the file, or you'd have to change your SERDI, or you'd have to have some way of excluding those from your results, which might be expensive in query performance, and might also not be possible depending on what your columns look like. So you generally want to remove your headers before you load the files. Text file is a very, very common format. It's used in all of the examples I have pasted into the notes and in the slides themselves. And if your data is going to be shared across multiple systems, if it's also going to be processed by something other than Hadoop and Hive, text file is quite likely what you're going to use. And if your data is all alphanumeric, it's very easy to use a text file. You can always add whatever you want through a SERDI if you're willing to take the effort to write that. And again, this is a programmer's heaven, so everything is customizable and extensible. So I've talked a little bit about SERDIs. So if you want to use a SERDI, such as the JSON SERDI that's in the example here, then you reference that in your create table statement. And again, you can create your own. You have to include how you want to parse the data when it's coming in and going out, and you have to write your own optimization. And you can override the create table statement. So you could in your SERDI require different things in the create table statement than what we have in our examples. And again, XML, JSON, comma separated values are very common SERDIs that are out there. So I talked a little bit before about ASV. So Hdfs is the distributed file system that comes with Hadoop. ASV is based on an API that's available in Hdfs, and we've written our own so that you're able to access data in blob stores in the cloud. And it allows you to reuse data across clusters. And again, this can be a huge money savings, because you're able to spin up a cluster. Say that you have a project and this the project is only going to last 2 months. Well, now you spin up that cluster, and at the end of that time period, you spin it down and your data is still out there. Maybe next quarter you need to use that same data, or maybe some other project also needs to use that same data. That data is still out there in those blob stores. It does not go away when your cluster goes away. It also makes the data available very quickly. So your data can be loaded ahead of time before you even create the cluster. And again, this can save you money in terms of how long your cluster is up. So I talked about indexes, and they're not really useful in a lot of scenarios. So if you have data that you would normally have to partition into very small partitions, which is not usually very performant in the Hadoop world. Or if you have some group bys, you might find that indexes are useful. And again, that's in the current version of Hive, just 0.9. That may change in future versions. But you can go in and say create an index, and then you can afterwards say alter and rebuild. As soon as you do that rebuild statement, you're creating another copy of the data in the indexed format. And so you're using a lot of space, and it's static data. It's materialized into that index. So until you go back and say alter, index, rebuild again, any new files that are added to the system, those would be immediately available to the underlying table, but they're not available through the index until you say alter, index, rebuild. You're not really specifying keys here also, so that's something to keep in mind as well. They're not quite the same as indexes that we're used to in the SQL Server world. We do have views in Hive. So you can create a view just like you would in SQL Server, or very similar to how you would in SQL Server. And this is not materializing the data. So it's not making another copy of the data. It's just making the query consistent across multiple queries. And it's pretty much the same syntax as you would do a select from a table. And it can have an order by or a limit statement. And a limit is similar to the top statement that we're used to in SQL Server. So instead of saying select top 200, in a Hive QL statement, you would say select star from where limit 200, and it would only return 200 rows. So those things are allowed in a create view statement in Hive. So we've talked about how to define the metadata. So let's talk a little bit about how to get the data back out after we've got our tables and views created. For those of you familiar with T-SQL, very, very similar. So again, other than the limit statement at the bottom that's replacing top, this could be ported directly from a T-SQL statement. And again, there's minimal caching, there's basically no statistics, basically no optimizer, and it's doing a table scan every time. It's reading that entire data set. Now, if you have partitions, there are exceptions. If you have your partition key in your where clause, it'll do a table scan of the partition or partitions instead of the entire table, but it's still basically, think of it as doing table scans. And the way you write your query does matter much, much more than in T-SQL. So I say you can take a T-SQL query and just cut and paste it in, but it may not perform as well. You may need to go back and change the order of the items in your from clause, for example, or change something else that a cost-based optimizer such as SQL Server could resolve and figure out. In Hive, again, programmer's heaven, you get to control everything. Of course, the downside of that is you have to control everything. You can't rely on a lot of automation or things happening in the background. One thing I do want to point out is huge number of aggregations are available within Hive. So you can do count, you can do union, you can do round, all of the things that you might think of as common BI type of syntax. A lot of those are available. Those were the first things brought into the system because quite often Hive is used as a warehouse of some sort, and those are the types of queries that you will be doing. You can do sorting in various ways. There's an order by, a sort by, a distribute by. They have different bottlenecks. So an order by comes back to one machine at the end. It has one reducer. So when you map, you're mapping out the tasks to many data nodes, and when you reduce, you're reducing the data back down. If you have an order by, you're saying, I need things exactly in order, and Hadoop says, okay, I do that by putting it all on one machine and sorting through it. And that can be a really big bottleneck. So what you can do instead is a sort by, which says within each reducer, I want to sort. And because I also chose distribute by, my data in theory is probably distributed in a way that I can just add those together and get back pretty reliable, pretty close to an order by. But it's not necessarily 100% guaranteed, but it can be a huge performance savings. And in most cases, you don't need 100% order anyway. And that does work better if the data is evenly distributed by whatever you choose in your distribute by clause. We do support joins in Hive. They are, however, limited. A quality is going to be the most common. You can do an outer join and a left semi-join. You cannot do not equal to. You cannot do a if exists type of query. Those have to be rewritten as some other type of query. And that's because those are very hard to translate to Mapreduce code, especially automatically. If you need to do something that complex, you need to rethink whether you should be using Hive. You might be able to write it in Mapreduce, but again, it's going to be very difficult. Maybe if you're asking those sorts of questions and those sorts of queries, maybe your data is in the wrong place. One thing here is that it is possible to have multiple Mapreduce jobs in a single Hive query. It's very likely, as a matter of fact. And you want to put the largest table last, which I've been referring to as the order matters. And that's going to really change the memory characteristics on the machines and really change the performance. And joins are done left to right. And the join on clause is always evaluated before the where clause. So those are some things that could be gotchas when you do joins in the Hive world. So if you want to go out and look at the metadata, you can, I'm sorry, not the metadata, the execution plan, such as it is. And again, there's not an optimizer here. So you can do explain or explain extended, and some of the detailed output of that is in the notes, but basically it's going to tell you a little bit, not a whole lot. There's very little documentation on how to interpret it, but kind of think of it as a very, very primitive version of a show plan in SQL Server. It's extremely limited in what it can do, but it does give you some information. So it's a start, and if it's something you're passionate about, you know, go out to the Apache community and start looking at what people have proposed in that area and see if you can add something to it. So let's talk a little bit about configuration. And basically, when you configure Hive, many things come pre-configured, but again, programmer's heaven, you can change anything. So if you're going to launch Hive, you go to one of the preset directories, which is the Hive home, and you go to bin. You type Hive. You can go on into the install directory, which with our current version of Hdinsight is the one listed here. It'll default to the C drive, Hadoop, Hadoop-1.1.0-snapshot. Within there, you'll find a configuration or a conf directory, and you'll find quite a few XML files. And here's where you can change the defaults for your head node. So when you remote into the head node, the kind of the control node of the system, you can go in and change all these settings, and then you could push those out to the data nodes as well. The ones that are relevant to the data nodes have similar XML files, which generally are copies of the ones on the head node. You can change just about anything you want. You can also override almost all of those settings on your individual Mapreduce settings in your code. You can do set statements within Hive that will override the configuration variables, and you can actually, if you're going to go in and write pure Mapreduce or use one of the other tools, most of those tools have ways to override the configuration settings as well. And one thing to be aware of is there is a log file, log4j, and you can get that also in the configuration, or you can set the properties of that in the configuration directory, and the output is in the log directory. So we're just about out of time here. I think I've gone a little bit over my hour. So let's talk about some of the things we've learned and some of the ways that you can keep working on this. One thing is, you know, why are we here talking about Hive? You know, I assume most people here come from a SQL Server world or an analysis services world, just based on the audience and the fact that it's pragmatic works. But really, we're here to talk about Hadoop and Hive because it is the buzzword. It is what is going on in the world. It's where people are looking at expanding their horizons. It's the next new thing. And it's not going to look the same in a year as it looks now. It's not going to look the same in 5 years, but the thing is you need to get in on the ground floor. It does allow you to do BI on top of big data. You can go in right now. You can use Data Explorer, which is a preview Excel add-in to find the data. Then you can pull that data into Power Pivot in Excel or into Analysis Services, which is the server-side version of Power Pivot. You can pull it into AS Tabular, and now your data is accessible in ways you're used to via Odbc, via different BI tools that you want to use. You can put Power View reports on top of your Power Pivot data model. And once you've pulled that Hive data into Power Pivot, it is now highly compressed. It's in memory of either the AS Tabular instance, if you chose to go the server route, or in memory of the Excel client machine. if you chose to use Power Pivot, and it's highly compressed, so you can have a lot of data there, and you can access it just like any other data. You can mash it up with your SQL data, your Azure data, your blob stores, whatever else you have access to is all available in that same data model. So it is something your users are going to be asking for, they're going to be using, and you need to get ahead of it and stay out there. And again, you can reuse a lot of your SQL skills if you start with Hive as your way to get into the whole Hadoop world, and make sure that you're using it when it's appropriate and not just because it is the buzzword. It is used when you want to do batch processing, when you want to iterate through things, when you're looking for new insights, when you're trying to figure out what questions you should ask, when you have the unknown unknowns, you don't know what you don't know. That's where Hadoop is very powerful. So make sure that you're using Hadoop in the right way, and that when you use Hadoop, you use Hive appropriately. And that requires getting into it now and understanding something about when you would use each piece of the technology. So there's a Getting Started blog that Laura Rubelke wrote. Programming Hive is a wonderful book. You can also get the definitive guide to Hadoop. That's very good also. But again, from a SQL Server perspective, I think the Programming Hive is a better first book because it does talk in terms that SQL professionals are used to. The definitive guide is good as well. It gives you an overview starting from the Mapreduce side and working its way up towards Hive and Pig later on in the book. It's maybe not as intuitive of a way to get in, but it is much more of an overall explanation of the entire ecosystem. I have quite a few blogs up there. I have a blog on Hurricane Sandy where I walk through in great detail how to upload a data set from multiple sources into a combination of SQL Server and Hive, how to create Hive tables on top of that data, and then how to put a Power Pivot model on top of those various data sources, and then create a Power View report. So it introduces you to multiple technologies in that blog. I have an explanation of internal and external tables with a demo you can walk through and things like that. Also, you can go up to our system and ask to be in the Hdinsight service preview, or you can download the Hdinsight Server one box. So basically, those are both previews. The Hdinsight Server right now is a single node install. It's great for testing functionality, for getting your feet wet, for figuring out what's going on. You don't have to have an Azure subscription. You can just download it. If you need a multi-node install, you can go out to Hortonworks. So they've got the pure core Hadoop pieces available to run on Windows. You can download the Hortonworks distribution. You do have to do all of the install yourself. And, you know, it is a bit involved to do so, but if that's what you think you need, you know, it's out there. It's not going to have the add-ins such as JavaScript and monitoring and some of the things that are Microsoft only, but it is the core Hadoop components that do run on Windows. Really, the big thing you need to do is start thinking about how big data fits into your company strategy. Make sure you decouple the terminology of big data from Hadoop, because big data technology might be SQL Server, it might be analysis services, it might be PDW or Stream Insight or RX or some other technology that you are already familiar with. You can use those technologies in some cases to fit some big data needs. So make sure you understand what's going on in your company and head off things that are going to get projects going down the wrong track. So really you can be a very powerful force in your company. So here's that definitive guidebook, the Hadoop, the definitive guide, and several other references that you may find useful. I really do recommend you just go out and start reading, start doing something. And hopefully we've covered all the things that we talked about here at the beginning. And I really, really appreciate all of you coming. And again, I do thank Pragmatic Works for inviting me to speak today. And please visit my blog, blogs.msdn.com/Cindy Gross for this slide deck and lots of other interesting information on BI and Hadoop and SQL Server. Thank you all for coming.